So, given any number n number of stocks where n is a number, it can be 10 or 12 whatever it is. If you consider the concept of the variance and the expected value, so there would be n number of variances and n number of expected value. But what is also required is basically what is the interrelationship between two random variables, which we basically denote by the concept of either correlation or covariances. So, if you are able to draw the covariances between these n number of stocks, what we get as we were mentioning is that we will basically have a n cross n matrix as shown here. And this n cross n matrix basically would have a principal diagonal, which would be, listen to, if you listen to it very carefully and understand, is basically the variances of all these n stocks or the covariances of the n stock with itself. So, the first one would basically be the covariance of the first stock with itself, and the last one would basically be the covariance of the nth stock to itself. So, which are basically the variances, and the of the diagonal element are basically the covariances. So, if you use the concept of the formula of the covariances, the covariance formula would be given by this, where this x is basically the first random variable, which can be r1, minus this expected value, which is the first moment of the first random variable, which is r expected value of r, multiplied by y, which is the second random variable, which is r2, minus the expected value of y, and then you basically find out the covariance of between x and y would be given by, as you are writing down, would be the expected value of this. So, and at the end of the day, when you basically solve, so what you actually get would be this rho, which is basically the correlation coefficient existing between two different random variables or two different stocks, would be given in the initial, in numerator you will basically have the covariances, and in the denominator you will basically have the standard deviation, which would be sigma suffix x or sigma suffix r for the first random variable and sigma suffix y for the second random variable. So, we will denote this correlation coefficient as x and y. Technically what we want is this r1 comma r2, where r1 and r2 are the random variables. So, if you consider the principal diagonal, what we have is r again, as I am repeating it, are the covariance of the random variable with itself or the covariance of the particular price of the stock with itself, which are the variances, and of the diagonal element of the covariances. So, remember, if you use this formula of the covariances, they are equal in the sense they are just mirror image of each other. So, that means the first element which is in the first row second column is exactly equal to the second row first column value, which is basically the covariance of the first to the second or the covariance of the second to the first. Now, remember here that we will be coming back to this correlation coefficient again. Now, if you have gone through the syllabus, at a later part of the course we will discuss what is copulas. Copulas are, in a very simple sense, I will just introduce, not from the theoretical point of view, but I basically mention that the copulas are some sort of linkage functions or linkages, which basically gives that the characteristics between two random variables, how they vary amongst each other. So, if you consider the linkage function as a correlation coefficient, so you will basically use correlation coefficient. In case if you do not think correlation coefficient is a good measure between the linkages, we will use the concept of copulas, and which is very heavily used in the area of finance. We will consider that later on once we solve the first set of problems. So, what actually we have, again I am repeating, n number of stocks, n number of expected values, n number of variances, and their corresponding covariances between them, which would be NC2 in number. But obviously, remember they are equal with respect to the principal diagonal. So, now we have a portfolio, we want to formulate a portfolio. Now, for whenever you are trying to formulate a portfolio, remember that as an initial amount you have some amount of money, consider that is capital W, which is the wealth, if you remember. Now, what we consider in a very simple sense is that total amount of wealth is divided into some proportions, and you have invested that amount of proportions in those n number of particular stocks. So, if you consider the total amount which you have spent in the first stock is 10 rupees out of the 100 rupees which you have in your pocket, hence the overall weight which you are investing in that particular stock would be 10 by 100, which is 0.1 or 10%. If you consider you are investing 20%, it will be that you are investing 20% of your total amount of money in that particular stock. So, we are using for the first time a variable which are known as the weights. So, such that given n number of stocks, they would basically have Ri, where I basically changes from 1 to n as the random variables. They would basically have the expected value, which is the basically the first moment, as we already discussed. Then you will basically have the variances, the covariances, along with that you will basically have the weights. So, what you actually need is that given any particular portfolio, you want to find out the optimum portfolio such that you can find out the weights such that the overall combination of the portfolio will give you the best benefit. Now, I am using the word best benefit, it means that depending on what your actual outlook is, whether you want to basically increase your expected value, whether you want to decrease your variances and so on and so forth. So, the simple formula based on which you find out the expected value of that portfolio. So, this P word is basically being used for the portfolio, remember that, would basically be the expected value would be found out using Ri bar, where bar is basically the expected value given you have basically a sample, and what is a sample, I am going to come back to that within 2 minutes, multiplied by the weights. So, these are Wi's. So, it will be, if there are n number of stocks, the first term would be W1 into R1 bar, second term will be W2 into R2 bar, so on and so forth. Now, why we use a sample is in a very simple sense, that I will basically step aside and basically give you a small definition, that given actually the overall information of that particular random variable, its total population. Population means that the whole set of information which you have, in general it may not be able, we may not be able to find out the overall random variable values which are the realized value for the whole population. So, what we do is that we basically take a chunk, and that chunk is basically one of the samples, such that we choose the sample in such a way that basically it mimics all the properties of the population which we have. So, we consider that if the expected value for the population is not known, we basically we take a sample average, that is the expected value of the sample in a very simple terms, and that is basically denoted by R bar or say for example x bar, depending on whatever the random variable is. So, given the information of the sample average, which is R bar, and the weights which is Wi, W1, W2, W3, whatever you have, you will basically find out the overall the return of the portfolio, the expected value of the portfolio given by the summation of Ri into Wi. Now, given the expected value of the portfolio, we will also be interested to find out what is the variance of the portfolio. So, if you remember, we had basically the variance covariance matrix. So, what you do is that simply you find out the double summation of Wi into Wj into the covariance which is existing between the random variables ing or R1, R2, R3, whatever it is. So, if you consider the first element which you have in the variance covariance matrix, it is basically the variance of the first random variable with itself. So, it will be basically multiplied by W1 square, where W1 is the weight for the first random variable. If you consider the last one, it will be basically be the variance of the nth stock or the nth random variable which you have with itself multiplied by Wn square or Wn suffix square basically. And the off diagonal element will be multiplied by the corresponding weights for the first and the second multiplied by the covariances which you have. And also remember, which is technically true, that if we have basically n number of stocks, we will consider that the weights are W1, W2 to Wn, hence the summation should always be equal to 1, irrespective of the fact whether you have, I am using for the first term the concept of short selling. What is short selling? We will come to that later on as we solve the problems. If it is a very simple case that you have basically n number of assets or n number of stocks, you will basically try to utilize in such a way that you find out the weights such that it basically gives you some benefit based on which you are trying to basically find out the best optimum solution. Now, what we do is that we want to basically find out that how does those particular stocks or those particular portfolios look in your overall picture. That means, we are trying to basically draw for the first time that how they look on a Cartesian coordinate. So, in the Cartesian coordinate, what we have is along the x axis we have the risk or the standard deviation of the variance, which is the second moment which we are talking about. Later on, we will see that how other different type of second moment, how other different type of risk can also be utilized in order to basically draw this graph. And along the x axis, you basically have the returns, which is the first moment. So, what we are trying to do is that on the y axis, we are trying to basically draw or picturize or plot the positive benefits which happens for any investment, on the x axis these are basically a set of negative benefits which happens. So, if you basically have different type of assets, so they are basically plotted by this pink curve. So, this security would basically have a return which is given here and the risk which is the variance. Similarly, for the second stock, you will basically have this and so on and so forth. So, what is now important for us to formulate is basically find out those weights based on which all these different type of securities which are there can be combined such that you can basically formulate a portfolio depending on what your main concern is. What is the concern and how you basically formulate the portfolio. Before we solve that, we will give you a brief introduction that what you basically mean by the combination of this n number of such so called financial assets or financial scripts which you have in front of you. Now, we consider for the first time the concept, as I mentioned, the concept of short selling. So, short selling in a very simple way consider that you want to basically formulate a portfolio, but you do not have that a particular stock in with you. So, what you do is that you basically borrow it from the second person and formulate that in your portfolio such that after a time expires you basically return that particular asset or the financial instrument back to the person from where you have basically borrowed. So, technically it means that you do not own that particular financial asset, still you are trying to formulate in such a way that it is utilized in such a way that you are able to maximize your return or minimize your risk or whatever you want to do, considering that it had been considered in your portfolio as one of those single component which basically forms the overall portfolio. So, say for example, you have n number of assets, it may be possible that the third, fifth and the sixth are short sold, in the sense they have been borrowed from the other person, they have been combined in order to basically form the portfolio. So, now again without going into the repetition, we will consider the returns to be basically smaller. And remember also, if you consider later on, if you mention that I mentioned the word that summation of the weight should be equal to 1. So, if there was no short selling, all the weight would be basically between 0 and 1. But if there is short selling, then it will basically mean that some of the weights technically can be negative. Still we will consider that the summation of the weights to be 1, but with the fact that the weights are not the actual weights, but they are the normalized weights. How the normalized weights are found out, I will come to that later as we solve the problem. So, our main concern is basically to have set an investment policy, and the last concern would be basically to evaluate the performance of the portfolio. So, our main thrust would be to formulate the portfolio such that we are able to basically analyze the portfolio depending on what the human being's outcome is. So, as we discussed in the in the investment policy, it will involve determining the investor's objective. In performance security analysis, the main step would be basically to find out how the security analysis can be done such that we can basically study those particular financial assets such that they can be included in the portfolio. We will very briefly go to the technical and fundamental analysis later on, where different type of chartings would be done in order to find out what are the different type of performance index based on which a particular security analysis or study is done. Next, we will basically consider how you construct the portfolio, that what are the different type of timings where you want to do, how you will want to basically formulate the portfolio, what are the weights you want to do, and based on the total outcome of the overall decision process, you will try to basically analyze your decision based on the fact that based on what you basically went forward and basically made the investment process. And once you basically are able to compare your actual output from your portfolio analysis, and then basically are able to compare what is the difference between difference which exists between the portfolio which you have formulated and the portfolio based on which you have actually started, we will basically revise the portfolio. So, that means either some stocks would be brought into the portfolio, or some stock would basically be taken out of the portfolio such that the overall impact of the change would be such that it mimics the actual values or actual sense based on which you have basically started your portfolio analysis at the beginning. And then you will basically consider that what are the different type of measures of how you analyze the portfolio. So, the measures can be either the expected value, can be the variance, or can be some other type of risk measures which you can consider if the returns are not normal. If you remember, I mentioned that technically or theoretically the returns are considered to be normal, but they are not normal. But what are the different type of risk measures you will try to analyze in order to analyze the portfolio which you have. Now, what we want to analyze is that given those n number of assets which you have, or financial scripts which you have, or the stocks which you have, and if we consider the diagram which you have just considered, there was a Cartesian coordinate. Along the y axis we had basically the returns, along the x axis we have the risk, the variance or the standard deviation, whatever it is, and we had with different points. So, consider we had 4 different points, you want to combine them in such a way that will give us the best benefit. So, what we want to find out is that given n number of assets, how is it possible to find out the best combination such that it meets our demand and criteria based on which a particular person is trying to invest. So, now we will consider for the time being that there may be initially there may be only n number of assets which are risky. So, risky means the word basically means very simple that there is some return and there is some variance or there is some standard deviation. Later on we will relax that assumption where we will consider both the risky assets as well as the risk free interest rate or as an asset, and then basically we will combine different type of coupons, different type of bonds such that the portfolio becomes much more complicated in the sense you actually consider much more practical situations into the portfolio and are able to analyze the problem from the point of view of the theoretical sense, so that once you understand the actual theoretical formulation you are able to basically analyze that portfolio which has all the realities into its overall structure. So, what we will consider is that a person has bought a particular asset, sold that particular asset such that the prices are given the prices, the returns can be found out, consider the returns are normal as we have been mentioning. You find out the expected value, you find out the variance, you find out the covariances, and based on the fact that you have found out the covariances, you want to basically proceed to find out that how you can formulate the portfolio. So, as just a recap, you can find out either using the capital R, which is the total return, or you can basically find out the small r, which is the total rate of return. So, given excess, which are the investment amount, the relationship between the amount of investment can be found out that x and small r are given by the last formula. We will come to that later on also. So, consider that if you have 100 rupees in your pocket and if you invest in a bank at a interest rate, simple interest rate of r, so the overall amount of money after 1 year would be given by this. That means, if the interest rate is 10%, so you get an interest rate of 10 rupees out of the 100 rupees you are investing, such that at the end of the day you will get the actual initial amount which was 100 plus the interest rate of 10. So, we would basically consider r as in a very simple case a return based on which we are able to analyze our investment. So, consider that now we want to formulate a portfolio with n number of assets where all the expected value, the variances, the covariances are given, and you have the formula that how you can find out the expected value of the portfolio also, which is, if you recap, it is basically a summation of the weights multiplied by the corresponding sample average of the expected value of the sample, which is Wi into Ri bar, sum them up for all the n number of assets. And when you have the variances, you can find out the variances of the portfolio by multiplying the weight square, which is W1 square into sigma 1 square, where W1 square is the weight square of the first one, sigma 1 square is basically the variance of the first one. And if you follow the principal diagonal which we already discussed, the last element in that particular calculation would be Wn square into sigma n square, and the of the diagonal element will be considered twice, which basically is the multiplication of the weights of one to each other, that means W1 into W2 or W3 into W4 and so on and so forth, multiplied by the covariances, and you can use the formula where the covariance is given by the formula which is basically the multiplication of three terms, which is the correlation coefficient, which is the standard deviation of the first and the standard deviation of the second. Now, as all if you remember, given the returns of the portfolio will be given by this formula where I put the tick mark, and the expected value once you find out would basically result in R bar, which is the expected value of the sample of the portfolio, such that you have utilized the sample corresponding to the fact that there are such expected value of the n number of portfolio which you have, which is basically R bar I. And given that, you can basically find out the expected value of the portfolio given by this R bar n, R bar p. Now, consider that for the portfolio, if we have two different portfolios, so obviously the formula would give you, if the overall weights in the first one is alpha 1 and the weight for the other one is alpha 2, such that alpha 1 plus alpha 2 is basically 1. So, obviously the return would be given by alpha 1 into R1 bar plus alpha 2 into R2 bar, and then you find out the overall portfolio which is Rp, and I am putting a number 2, which means there are definitely two number of such assets. Similarly, you can find out the variances, which will be sigma 1 square into R bar 1 into so it will be, so it would be like this. Sigma 1 square is basically the variance multiplied pre-multiplied by alpha 1 square, which is the weights. Similarly, the second term in the 2 by 2 matrix, now it is n is basically 2, you will basically have alpha 2 square into sigma 2 square, and the of the diagonal element would basically be alpha 1 into alpha 2 into the covariance of first and second, such that it will be rho, which is the correlation coefficient, multiply sigma 1 into sigma 2. So, there were 2 elements, so obviously it will be twice. Remember also one thing, the weights always equal to 1, and also remember, if there is no short selling, this would be true. That means all the weights are between 0 and 1. Obviously, if there is short selling, this may not be true. Such that sum is equal to 1 if there is no short selling, where Wi's are the weights in the general sense. Non-normalized case would also result that. And in case if they are short selling, so rather than finding out the weights is equal to 1, what we need is basically to find out the normalized weights. So, I am putting the concept as normalized weights. So, how you find out the concept of normalized weight with respect to Wi's, I will come to that later on as we solve the problem. So, our main concern is, again I am repeating, there are expected values are given by this formula, where capital R or small r would be immaterial, whatever you use basically is fine, as long as you understand the concept. And then the variance would be found out using this formula, where these last 3 terms, if they combine together, is basically the covariances existing between the ith and the jth term. Now, our main concern is basically to formulate the portfolio in such a way that you are able to find out the weights such that the overall risk in the long term for the portfolio is minimized. So, basically that means diversification, that means I am able to put all my amount of money in different type of stocks, such that the overall risk or the overall variance or overall standard deviation of that particular portfolio is minimized to the maximum possible extent, depending on what my scenario is, that what is the total amount of money which I have, what is the total number of different type of stocks which I have, I want to do. So, basically given the fact that I want to diversify, plus the fact, if you remember, I mentioned about 2 properties of in utility. One was basically concept of non-cessation, where that means more I give you, more you want, and the other one being that any human beings can be classified as risk lover, risk hater, and risk indifferent person. So, if you are able to combine these 2 characteristics, we will be able to finalize and have a very good look that how the diversification happens, and how diversification along with these 2 utility concepts can basically give us the best picture that how the portfolio analysis can be done. So, consider in a very simple case, you have 2 different stocks, and I am considering capital R. Again I am repeating, it does not matter whether you consider small r or capital R. So, the capital R values are given at 12% and 15%, and standard deviation for the first is given as 20 or 20%, whatever it is. Secondly, for the second one is given as 0.18, and the correlation coefficient is given by 0.01. So, if you assume a portfolio which is being formed with 75% from the second and 25% from the first. So, you can find out basically the expected value and the returns for that, such that you can basically find out what the expected value and the returns of the R for the portfolio are, based on the fact that the weights of them is 25% and 75%. Now, remember, this may not give us the portfolio for which it gives it the best characteristics. So, our main concern would be, if you want to basically increase the returns and find out the best returns, what you will do is that basically you are trying to find out the expected value being maximum value. So, if you look at this formula, what you have is this basically is the risk, and if you look at this formula is basically the return. So, actually if I have rather than 25%, if I basically alpha 1 here and 1 minus alpha 1 here, which means R bar P or small r bar P, which is the return on the portfolio, is now basically a function of only one variable, which is basically alpha. Because if you consider, if the rate of returns are already given a priori from the past data, obviously you will find out their expected value and variance, and try to basically find out the expected value of the portfolio and the variance of the portfolio. So, in this formula what you will have is basically alpha 1 multiplied by its return, which is R1 bar, where R1 bar is known, plus 1 minus alpha 1 is basically the investment which you are doing for the second stock, multiplied by its R1 bar. So, if you want to find out the portfolio for which you get the best return, simply what you will do, you will basically differentiate this value of the return of the portfolio with respect to alpha, put it to 0, and then again you double differentiate the function with respect to alpha d2 or d alpha 2 again, and check whether it is greater than 0 or less than 0, and based on the rule that for the maximization and minimization you basically take that if it is less than 0 you would get the maximum point, if it is greater than 0 you get the minimum point, and then you can find out that value of alpha which will give you the maximum return. On the other hand, if my main concern is basically to minimize the risk, so what I will do in this equation, what you have again they would be alpha. So in this case you have basically alpha square, in this case you have basically alpha into 1 minus alpha, and in the last case you have basically 1 minus alpha whole square. So if you see the whole equation, again it is basically a function of only one variable which is unknown to you. So again you differentiate with this with respect to alpha, and again basically find out the second differential of that function, which where the function is not now the return, is basically the risk. So if you double differentiate with that and then find out that the value is greater than 0, which is for the minimization one, again you will find out some value of alpha such that will give you the minimum so called risk of the portfolio. Now if you consider any problem for where you want to maximize the return or minimize the risk, they would not be the same alpha values, so they would be different. So if I am a risk lover, or basically I want to find out, let me put it very simply before I go to the concept of risk lover. Consider that I am a person that where I obviously hate risk, that means I want to minimize. So obviously I will use the second principle as that finding out the differential of that variance with respect to alpha, putting it to 0, and then finding out the double differentiation and checking is greater than 0 would basically give me the value where I minimize my overall risk for the portfolio. If I want to increase my return to the maximum possible extent, what I will do, I will basically differentiate this function with respect to alpha and then find out for the case where it is a maximum value and basically formulate my portfolio accordingly. So for ease of understanding the concept of diversification, so obviously there would be different values in between. So consider you have n number of stocks, the prices of the assets are moving in such a way that their respective prices are almost always uncorrelated. So if they are uncorrelated, if you consider the correlation coefficient is 0, so if you consider the variance covariance matrix, along the principal diagonal you have the variances, and along the covariances the value would be 0. So that means rather than having n variances plus the nc2 values of the covariances which you have, that means they are counted twice. If you remember, what we have is basically the off the diagonal elements are 0, so you have basically n number of terms only. The return of each portfolio are considered to be the same, which is m. The variance of each stocks is again considered to be the same, which is sigma square, and also you consider that you are investing equal proportions of your total amount of money in this n assets. So with this simplification, what you will have, all the weights are equal to 1 by n. If you have that, and if you basically try to utilize that in the formula to find out the expected value of the portfolio and the variance of the portfolio, the actual formula which results is return on the portfolio is given by m, or the average return which you have for each stock, and the overall variance of the portfolio is given by sigma square by n, where n is the number of stocks. Now if I am able to draw the variance of the portfolio with respect to the n value, you will see very simply the numerator is constant. So as you increase the value n, it basically be a curve such that is asymptotically becomes 0, which means technically and theoretically there may be cases where you formulate a portfolio in such a way with the conditions as we have just discussed, that you can make the overall variance of the portfolio in the long run 0, depending on the fact that you have taken infinite number of basically assets in your portfolio. So this is the essence of diversification, where you combine the assets in such a way depending on some weights and in such a way that the overall risk for the portfolio can be made as low as possible. But that is technically not possible. Why it is not possible, we will come to that picture within another 2 minutes. So thus we consider diversification of the portfolio with only few assets subject to high degree of risk, but that risk would basically, we will see that it can be divided into 2 parts. One with the risk which can definitely be diversified, another set of risk which cannot be diversified. We will use some technical terms later on, but still let us follow with our simple example and try to basically analyze our problem, how we are able to basically delineate or draw the portfolio curves for depending on different type of weights, so that we are able to draw the efficient frontier or try to find out the portfolio based on which we can make our decisions accordingly. Consider another example now with correlated assets. So, in initial case you have uncorrelated assets, now consider the correlated assets, and with the sets of information you can find out now there would be a principal diagonal which is the variances of each stock, plus there would be a of the diagonal element. So, obviously, if you consider and you expand the equation, now you have two terms. The first term is basically dependent on n, such that as n increases this term can be made 0 technically, as you have seen in the last slide, but the second term which you have is basically always remain, which is basically the level of risk which you cannot diversify. So, what we are seeing for the first time is that there will be two sets of risk for any portfolio. One will be the set of risk which can be diversified in the long run and can be technically made 0, and another set of risk would be which cannot be made technically 0. So, in the theoretical sense, actually I am again repeating, risk can be made 0 if you are able in a theoretical sense to formulate a portfolio with certain assets, but in general it will be seen that you can minimize the risk to the maximum possible extent, where the overall risk or overall variance can be basically made into two parts. One is the diversifiable risk and another is the non-diversifiable risk, and we will see that later on as we proceed. Now, consider how we are able to draw. So, again going back to the same example, consider two stocks where the weights are alpha 1, 1 minus alpha 1, the variances are given by sigma 1 square and sigma 2 square, returns are given by R1 bar, R2 bar. If you have that particular portfolio which consists of two stocks, your actual values of the portfolio will now depend on one important fact, which is, consider B is the point which is the first asset, A is basically the second asset. So, if you combine them and if you have kept the value of alpha as changing whatever it is, and the rate of the returns and the standard deviations are different, but now if you bring in the correlation coefficient in the picture, there can be two extremes. One extreme is that when the correlation coefficient is -1, where you have this curve, and another case is basically in the correlation coefficient is +1, which is this curve. So, any value, say for example 0 may be this, minus 0.9.5 can be this, plus 0.95 can be this, and so on and so forth. So, what we are doing is that we are trying to basically formulate a portfolio such that the value of the portfolio depending on alpha, depending on R, depending on sigma would be such, and depending obviously on the correlation would always be some point inside that triangle. Now, this is a very important fact. Once we are assured and when we are convinced in a conceptual sense that the point would always be in a triangle inside the triangle, we can basically proceed to the next step. But before we go to the next slide or the next step, remember the dotted lines which are given here are for the case where there is short selling. So, you will be asking that how is it possible? If you consider the straight line joining A and B, so a middle point would be what? Where you are investing 50% in A and 50% in B. If you consider point B only, it means that you are investing all of your money in B and not in A, and vice versa. But if you extend this the graph along this line or go down, it basically means that you are short selling one with respect to the other. So, if you go along this one direction along to infinity, that means you are basically trying to buy one of the stocks which you do not have and utilize that money into other particular stock depending on how you want to basically formulate your portfolio. Similarly, for a correlation coefficient of -1, these dotted lines along this direction and along these directions are the case when short selling is there. So, now the curve which you have, if you are able to solve it, how would you solve it? The question would be that because for the correlation coefficient being existing between -1 and +1, you will have the equation which is like this. This is sigma square, which is for the portfolio, is given by double summation of Wi, Wj, which are the weights if there are two number of stocks, and you have the correlation coefficient existing between covariance existing between two stocks. And if you have two stocks, what you do is that if you see the last slide, what you have is basically the y axis. So, obviously y axis would mean that the risk is 0. So, obviously if you put the risk as 0, you can find out the value of that particular stock such that the overall risk can be made 0 in spite of the fact there would be some return. So, before I go in and proceed further, this would give you some hint how risk free interest rate would be utilized later on. Thank you.